my previous video, I had discussed the computation of risk and return for two securities portfolio. Today I am going to discuss the special cases, basically for correlation coefficient value +1, 0 and -1. Finally also I will discuss any value of correlation, how you will determine the mix-up of two security portfolio for which the risk will be minimum. Actually that formula has been derived after a long algebraic process, application of calculus, basically minimization tools, but here I will not discuss the mathematical process, only I will use the derived formula in that case. Now first of all, this is the formula for computation of risk for two securities formula for two securities portfolio. This is variance of the portfolio. I have already discussed the risk may be measured by the value of variance, and if you square root it, then you will get the standard deviation. This is the standard notations. W1 means the weightage for security 1, W2 is the weightage for security 2, sigma 1 is the standard deviation for the return of security 1, and sigma 2 is the standard deviation value for the returns for security 2, and R12 is the correlation coefficient between the returns of the two securities. This is also I have discussed in my previous video. If you have any doubt, you can check from that video. Now I am discussing one by one the different situations of correlation value, how we determine the risk. Say this is the first case, the correlation coefficient value is +1. If you put the value +1 for this, then the expression will be like this. If you take this is whole square, then you will get this, and the value this is 1 +1. Now as this is variance, now if you square root it, that means standard deviation of the portfolio with the square root of this, or standard deviation will be this. That means if you apply this simple formula, then you will get the value of standard deviation or risk for the case when the value of correlation coefficient between the two securities is +1. This part is over. Now for R12 or correlation coefficient is equal to 0. That means you put the value of R12 is equal to 0, then this part will be eliminated, only this part will be remains. That's why the variance will be this, because the rest part is 0, and the standard deviation will be, you have to square root it. That's why square root SQRT means square root of this expression. If you put the value of W1 and sigma 1, W2, sigma 2, then you will get the standard deviation of the portfolio or the risk. For the case of correlation coefficient value is 0. One thing again I like to mention here, that it is understood that W1 plus W2 is equal to 1 always, as there are two securities and W1 is a proportion or percentage, you can say, for security 1, and definitely the next part W2 will be equal to 1 minus W1, because the total sum total will be equal to 1. Now when R12 is equal to -1, That case specially I have discussed in my previous video. If the correlation coefficient between the returns of the two securities portfolio, then the risk may be reduced even to zero. You can reduce the risk to zero. How the risk will be reduced to zero, that is also discussed in the previous video. Here again I have shown the formula. You have to mix in this proportion. How? W1, which is percentage of your investment of first security, will be calculated by this expression, sigma 2 divided by sigma 1 plus sigma 2. If you know this, then easily you can find out this 1 minus W1. If this is say 35%, then W2 will be 65%, as total is 100%. Or if you write it in decimal form 0.35, then W2 will be 0.65. If it is 20%, then this will be 80%. So whatever the value for minimum risk, in this case it is 0, will be determined by this expression. This is known sigma 1, sigma 2, and with the apply of this expression you can get the value of W1, W2. I have already shown one example in my previous video. You can check it on that video. Now I am going to discuss the general situation, means any value for the correlation coefficient between the two securities is given. Then you will apply this formula. This has been developed with the application of some algebraic process with the help of calculus. I have already mentioned it. W1 is equal to, this is sigma 2. Mind it, this is sigma 2 square minus sigma 1 into sigma 2 into R12. This is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 R12. All values are known to you. I think you know how to compute the standard deviation value, correlation value, that I have already discussed in my previous video. You can check it. For the two given securities, you can calculate all these values. Moreover, you know W1 plus W2 is equal to 1, as this is a two security portfolio. For any value, you can compute the proportion for which the risk will be minimum. It is not an arbitrary process. You cannot do it arbitrarily. I will show you in this problem itself. If you take any arbitrary value, the risk will be more. As a rational investor, you will always try to reduce the risk, to reduce the minimum risk. That's why you should have the knowledge of this. That is the importance. Now I am taking one example. Say this is a problem. The S and G companies, two companies shares in front of you, you are going to purchase. From the past records, you have computed the return from the company S is 15%. The return percentage for company G is 17%. The standard deviation is 30% for S, and standard deviation for company G for the returns is 25%. And the correlation coefficient between the returns for both the companies S and G is 0.5. We have calculated it. This is not plus 1, not 0, not minus 1. This value may be 0.75. This value may be any other value, 0.25 like that. Now the question, what will be the proportion of mixed portfolio for which the risks for the portfolio will be minimum? So in this case, this is the solution part, WS. I have shown you the calculation in the next slide. After calculation, this percentage has come. WS, one means S. This is the percentage. Then definitely WG will be this. And if you put WS and WG to the formula of the portfolio risk and with the correlation value of this, sorry, this will be SG. Some mistake is there, not R12, it will be RSG. Correlation between S and G is 0.5. Then you will see the risk will be minimum. How will prove the risk is minimum? If you change the proportion, then you will see the risk will be more. That I will show you later. And the expected return for this proportion of investment will be this. Now I am going to show you the detailed calculation with the help of this value. This is the formula for WS. Previously it has written as W1, as S and G are the securities or companies. So first, this is the weightage or mix up proportion, WS. You have to put the values. This is sigma 2 square minus, this is standard deviation, sigma S, sigma G, and this is the correlation value. This is sigma S square, sigma G square minus 2 into standard sigma S, sigma G into correlation value. We will calculate it. This is the result that we have from 0.32 to 5. This is the result. And if you put, then WG will be this percentage. The results have been put in the previous video. Now I am going to show you the detailed calculation through an Excel sheet, where I will show that if you change the mix up, then your risk will be more. Whatever the mix up other than this, the risk will be more. That I will show through the Excel sheet calculation. Now I am going to show you the Excel sheet. This is the calculation sheet. This is the portfolio formula. Square root W1 square, this is the carrot square, sigma 1 square plus this is square root W2 square, and this is the formula, general formula for portfolio risk, and this is the weightage which I have already shown you the calculation. This is the weightage for security S, this is the weightage for security G, and this is the correlation value. Though I have written 1, 2, but actually in this case it would be WS, WG, RSG, sigma S is 0.3 and sigma G is 0.25. And if you put all these values, this is the formula in Excel. In detail I have written the formula, and this is for WS. Now this is the minimum ratio. This is WS formula is this. This is WS 23.33% portfolio risk, and this is this is the portfolio risk formula. Actually we have put all these values to the portfolio risk. That's why you see square root of W1 is this value 0.3226 that we have written here, W1, and in this case the cell is okay. We have taken the cell. This is the formula, square root C7. C7 means, which is the C7? This is C. C7 is the weightage of this W1 square, and this is sigma 1 square. That's why C8. What is C8? C8. It is the standard deviation. You check minutely, then you will understand. Just this is a cell, dollar sign has put here to make it constant, because sigma value is not changing, only the proportion is changing. That's why I have set the formula in this way. For sigma 1, sigma 2 I have put the dollar sign, but for weightage of proportion C7 like that, whatever the weightage, and this is the remaining value. And if you put this value, then you will get, this is the proportion for which the risk will be minimum, that I have already mentioned. If this is the W1 or WS, then W2 will be 1 minus this that I have put in this problem the value directly 0.67 like that. Now I'm going to show you that for any changing of the proportion, the value will be more, the risk will be more. What is the minimum risk after calculating this that I have calculated? The minimum risk is this 23.33% after the result, putting the result. Now I am changing the proportion. What is the minimum proportion? The minimum proportion is this, W1 this, W2 this, or WS you can say, WD is this like that. But now I am changing, say I am taking W1 0.8, then definitely W2 will be 0.2. The sum total is 1. If you put in this risk formula, then see what will be the portfolio risk. This is the formula for portfolio risk. So standard deviation value have not changed. Only the proportion have changed. D13. D13 means this D13, 80. And this is F13. What is F13? W2 in this way. And the risk value is 26.85. For 80-20 the risk is 26.85, which is more than this percentage. The minimum risk is 23.33. You see all the risks are more. In this way I have calculated. You can test from this also. Suppose I am taking another 60-40. Suppose I am taking 90, 10, 90. W1 I am taking, this is 10%. 10%. And so W2, definitely that will be the 90%. 0.9. And calculate it. The risk has come 24.14. 24.14. In this way, through action sheet, you can calculate for different values of weightage other than the minimum one. You will see the risk will be more. The minimum is this, and all combinations the risk is more. Even if you take another combination 80-20 I have shown 20-80, then the risk will be this 23.57. Here it is 23.33. So 23.57, 0.2 and 0.8 that I am going to put it. 0.2 and 0.8. 0.8 and check it. The risk has come 23.57. 23.57. You need not to calculate in detail because formula I have already set here. This is the formula, exact formula I have set. Only the proportion W1 and W2 I am changing, and instantly you will get the risk value. But that formula for which the risk is minimum, that has come through a lengthy algebraic process by applying calculus minimization technique. So you can find out the value of proportion for both the shares, as it is a two security portfolio for which the risk will be minimum for any value of correlation. Even it is incorporated, you can check all the values, -1, 0, +1, 0.75, 0.85, whatever 0.65 of the correlation value. But that is the minimum if you calculate through that formula. That is the beauty of this process. Now, this already I have discussed. I am not going to repeat it again. Now next, this is a general message, as so many formula have been used. You practice it minutely. If you have any query, comments, suggestion, please give in the comment box, and definitely the reply will be given at the earliest possible. Even if you like to discuss, then please send your mail to this mail ID. Definitely I will contact and give time for discussion. Thank you. Thank you.